morning everyone, I'm Mr. Uppara. Today I'm going to teach about how to conduct a systematic review. First of all, I would like to understand the meaning of systematic review, how the students perceive. Matthew, can you define what a systematic review is?
From my understanding, a systematic review is a search followed by a review of the current literature of any given topic.
Charlie, what do you understand meaning of systematic review?
So similarly to Matthew, I think a systematic review is when you choose a topic and you assess all the evidence in that area to give you one conclusive answer about your research question.
Usman?
So similarly to the guys before, from what I understand of systematic reviews, when you have a given topic, you assess all the current evidence within that topic, then you conduct analysis based on that.
Yusuf, any other definitions you can give?
Yes, so similarly to my peers, I think that a systematic review is a literature review which uses systematic approaches to assess all of the current literature available on a certain topic.
That's very good. You all got basic understanding of meaning of systematic review. So I would like to say the systematic review is a review of the literature systematically from date of publication, from so-and-so date to so-and-so date, using search terms and search strategy, using various keywords and collating all the evidence in the form of Prisma flowchart, and then developing strict inclusion-exclusion criteria and going through the abstracts and full text articles and collating evidence towards the subject of interest, which is nothing but qualitative synthesis of evidence towards your subject of interest, is a systematic review. Before conducting any systematic review and meta-analysis, we need to identify the subject of interest. So these are the 8 steps how to identify the subject of interest and how to collate evidence from literature. The number 1 is to identify the keywords, collate all the keywords, and then develop a search strategy. Combine all the search results, export them into a software like Mendeley or any other software and then exclude unwanted or duplicates, and then apply filters, and then apply limitations, and then export again as an abstracts, and then go through the abstracts and develop inclusion-exclusion criteria. These are the 8 key steps in identifying the subject of interest.
Dr. Malik, you mentioned applying filters and limits. How do these differ from each other, and what are the exact function of these filters and limits?
So that's a very interesting question. So a filter is nothing but we wanted to separate human studies and animal studies separately. You can use something called not function in your search strategy and separate human studies from animal studies. Whereas limitations, you can apply limitations from some certain year of publication to certain year, like 2010 to 2020, or just simply limit to English articles or French articles or German articles. So the limit is you're limiting for a time period or certain type of articles, or maybe certain type of studies like randomized controlled trials or prospective studies or retrospective studies. Whereas filter, where you're separating clearly human studies from animal studies in a big search. So once you've done the inclusion-exclusion criteria, and those which fits into your inclusion criteria goes to next step, which is nothing but retrieving full text articles, and then you go through from line 1 to conclusions, and then if they qualify your inclusion criteria and if they still contribute towards your subject of interest, then you start doing something called data synthesis or qualitative synthesis, which is the final step, which is nothing but included studies for your qualitative synthesis and data synthesis. So in a Prisma flowchart, these are the 8 key steps. Matthew, I would like to ask the question, how do you pull the abstracts together?
I believe the easiest way to pull all the abstracts together is to use a referencing software such as EndNote or Mendeley to do this.
That's correct, Matthew. And so, Charlie, how do you remove the duplicates?
So often the software such as Mendeley or EndNote can remove the duplicates automatically. However, you can also do it by hand, but it's much easier and sort of safer to do it with a software.
Is it easy to do with the software, or is it easy to do with by manually?
It's easier to do it with the software.
That's very good.
Dr. Malik, at what stage do you develop the inclusion and exclusion criteria? Is it before or after reading the full text?
That's a very good question, Yusuf. If you develop inclusion-exclusion criteria after going through full text articles, you need to go through full text articles, plenty of them. So rather, you just go through the abstracts so that your workload will be less. once you go through the abstracts, then you develop inclusion-exclusion criteria, and then you go on to the full text articles, rather than developing inclusion-exclusion criteria after reading full text articles. And also it's very expensive to go to retrieve so many full text articles. So it's better you have inclusion-exclusion criteria when you're going through abstracts itself. And I would like to ask one more question. I said these are the 8 steps, key steps in developing Prisma flowchart. Do you guys know the meaning of Prisma, or abbreviation, what it stands for?
Yes, so from my understanding, PRISMA stands for Preferred Reporting Items of Systematic Reviews and Meta-Analyses.
That's correct. So it's an international agreement to collate all the evidence in a systematic review or meta-analysis.
Dr. Uppara, you've talked a bit about matching, but could you give us an example to help us understand it?
That's a very good question. As I said, you can match true positives with true positives. For example, if you're testing for the presence of COVID-19 infection, you can test either antigen or antibody, but both tests are different. The way to match them is to look for true positives with RT-PCR test. Let's say, for example, you used 2 tests, RT-PCR and antibody test. So with RT-PCR, how many true positives you resulted, and with antibody test, how many true positives you have. So you can look at how many true positives have as an outcome with one test, and you compare with that of other tests. That is what is called matching. True positive to true positive, true negative to true negative.
I have one more question. You mentioned a bit about statistical modelling. Do you mind explaining a bit more, maybe giving an example?
That's a good question. So what I'm trying to get statistical modeling, before even you go for statistical modeling, here we talked about logistics, like for example you stratify the various outcomes and then match them, which is nothing but logical hypothesis, where you try to match similar kind of outcomes or outcomes measured, so that you can next step go on to see if the data is homogeneous, number 1. Number 2, what type of distribution the data is, and is there any relationship between dependent and independent variables. So which is nothing but, if you want to test that logical hypothesis with the statistical models, which is nothing but statistical hypothesis testing. So to test hypothesis using statistical models, first of all we need to identify what type of data it is, whether it's homogeneous, and what is the relationship between various variables, and then is there a logic in conducting an equation, or in doing a regression equation. Is there a logic behind it? Now my student Charlie is going to do a demonstration how to construct a search strategy for COVID-19 drug treatments.
So when you construct a search strategy, you want to ensure that every element of your PICO criteria is included in your search. So you want to ensure you're searching for your population, the intervention, the comparator, the outcome, as well as the setting. But you can't just search for COVID, you need to include all the synonyms, because some studies may have tagged as COVID, some as coronavirus. So in this search strategy you can see here, we've searched COVID-19 as our population, patients with COVID-19. Our intervention is drug therapy, and we've combined these two together with the search function AND, which means that all studies that come up in this search have to include both COVID-19 and drug therapy. We then identify our setting by using randomised and trial, so we know that all studies will be randomised control trials. When we combine these with AND, all our studies have to have all 3 of these key terms. We then apply some further searches, and we use the NOT function. Combining our previous searches with a NOT function followed by animal studies mean we'll exclude all animal studies. It's a really good way for narrowing down your search and ensuring that your search contains only the studies that you need. As you can see from search 10 to 17 then, we then combine our previous searches with the AND functions to look at how many studies we have. We then apply some limitations, so we limit from 2019 to the current year, so our studies will only include any study published from 2019 onwards. And we then limit to original articles only, which means we won't include any secondary research such as systematic reviews. And as you can see, we ended with 24 studies, which is a great number to be able to search and export their abstracts and begin your systematic review.